Okay guys, what we're doing here is taking higher order derivatives, and what that means is that we are looking for the derivatives of our derivatives. All right, so we have been taking what we call first derivatives this whole time. Now we're going to learn that we can take a second derivative, and what that means is we take our first derivative equation and just take the derivative again. All right, there are third derivatives and fourth derivatives. They all tell us different things about the function. So what we're looking at in 1 through 4 is they gave us graphs and they said, hey, tell me which one of these is the original function, which one's the first derivative, and which one's the second derivative. So I'm looking at number 1 right now, and there are 3 curves. All right. So what I need to do is I need to look at it and see if I can find a relationship between these curves. Now what you are specifically looking for is where the curves cross the x-axis. This is going to help us a lot. And the reason that this helps us a lot is because you remember that derivatives equals 0 where graphs change from increasing to decreasing or decreasing to increasing, right? Where the slope of the graph is 0, the derivative is physically crossing the x-axis. So I'm looking at this, and I'm looking at my red curve specifically. And do you see how it's negative right here? It's under the x-axis, and then it crosses the x-axis there. I'm looking at this red curve, and I'm saying, well, if this is a derivative function, if it is, then I need another curve that has a slope of 0 at this point. It appears the blue curve does. This might help me. So let's see, is there any chance that this red line is the derivative of the blue line? The blue line has a positive slope, the slope becomes 0, then it has a negative slope, slope becomes 0, and then the slope is positive again. So our slope for this is positive, 0, negative, 0, and positive. The red curve would have to be above the x-axis, below the x-axis, and then back above the x-axis if it were the derivative of this blue curve. That's not what happens. In fact, the derivative of the blue curve would have to be positive here, and we see that the red curve is negative. What that tells me is that even though this red curve crosses the x-axis right here, the red curve is not anyone's derivative, all right? And so what I am going to do is I'm going to proceed as if the red curve is my original function, and we're going to see if I'm right, all right? So I think the red curve is my original function. And if the red curve is my original function, what that means is that I will be able to find a derivative, either this orange or the blue, all right, will be my derivative. So let's proceed as if the red curve is my function. It is increasing, which means the slope is positive. The slope becomes 0 somewhere right in here, and then it is decreasing. So I'm going to look at those other 2 curves and see if anything is positive, 0, and then negative. And in fact, what I see is that this orange curve is positive. It becomes 0 right here, which looks like it lines up with where the slope is 0 right there. And then it becomes negative. So I'm going to say, all right, the red curve is my function. The orange curve is the derivative of that function. Now I want to check and make sure that the blue curve could be the second derivative, or the derivative of the derivative. So can the blue curve be the derivative of the orange curve? So my orange curve has positive slope. The slope becomes 0. It gets negative, so positive slope, 0, negative, and it stays negative. It stays very, very slightly negative. So I look at my blue curve. My blue curve is positive, and right here, right where it looks like the orange curve is changing direction, my blue curve crosses the x-axis, and that tells me, yeah, that's looking like a derivative. My blue curve is negative and stays negative. And so you see that the blue curve is the derivative of the orange curve. So if I were putting these in order, if I were saying which one is f, which one is f prime, and which one is f double prime, A is f, B is f, oh no, and C is f double prime. Okay, and that's what I would say. You will notice that 2 right here and 4 both have 4 curves. They have a third derivative involved. You're going to have to do a little bit more with those. But what you're doing again is you're just looking and you're trying to identify what is my first curve, what's my first derivative, my second derivative, and then my third derivative. All right, so try that out. This is a common AP multiple choice question where you have to put something in order like this. So it's not a bad skill to practice. And if you have trouble with it, of course, we can talk about it on Monday.